Right, now we've got the data in a table. We now need to plot it in a graph, and this is the part that students find most difficult. If you look at the graph here, you'll see that again I've already drawn the axes. I've drawn them almost at the edge of the paper, giving me just enough space to put in labels. If you look at the labels that I've put down here, I've just copied these off exactly as they appear on the table. On the x-axis here, current in milliamps and potential difference in volts. Now we need to actually scale this, and this is where it gets really difficult. What I'm going to suggest to you is that when we look at the numbers that we put on these major divisions, they should be either 1, 2 or 5, or possibly 10, 20 and 50, or 0.1, 0.2 and 0.5. If you can make sure that your divisions are only those multiples of 1, 2 and 5, then the axes will be fine. So let's see what we've got to do. On the y-axis here, I need to record data between 10 volts and 40 volts. So if you look at the scale here, I would suggest that if we start with 0 there, 5, 10, 15, 20, 30 and 40. Let's have a look at the x-axis. My data now says that I need to record from just under 2 milliamps up to just over 7 milliamps. Now what am I going to do here? Let's start off by saying 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now again, to check whether these scales are working properly, I'm going to just plot the first data item and the last data item. So I've got a value of 1.9 at 10 volts. 1.9 at 10 volts gives me a data point there. My final point is at 7.4 at 40 volts, right the way up here. 7.4, 40 volts. So that's at that point there. Now, to see whether the data is going to be okay, what I need to do is to say, is the data spread over at least half the axis in the y direction? Yes, that one certainly is. Is the data spread over half the axis in the x direction? No, it isn't. You can see that that's just covering 1, 2, 3, 4, 5, about just under 6. And we've got 1, 2, 3, 4, 5, 6 more there. And another one down there. So we could certainly improve our scale on the x-axis. So what I've actually got here is I've got divisions of 1 for each major division. What I'm going to need to do is change it from having 1 to being the next number down. So I'm going to need to have 0.5. Now on this particular occasion, we'll actually find that if I did that, I would run out of space over there. So this is where I'm going to need to put in what we call a false origin. So I'm going to actually start at 1 and go up in divisions of half a milliamp. So that will give me 1, 1.5, 2, 2.5, etc. When I come to plot that data, you will find that the data fits much better, and there's a completed graph with those scales there, and you can now see the data easily covers the half of the y-axis and half of the x-axis. A difficult task there, but scaling the axes is one of the most difficult things that you'll need to do. Then it gets quite easy.